Right, good morning everyone. Thanks for joining us today. And my name's Steve Connor from Creative Concern. And I'm going to kick us off this morning. We've got an amazing group of speakers for you. Before we do get started, I'd ask everybody to stay on mute if you can. And I think everybody's got their cameras turned off apart from me at the moment. We'll be introducing people in and out as we go along. Before we kick off, just a couple of bits of housekeeping. What we'll be doing throughout all of this morning is having a mixture of keynotes and panel sessions. And if you have got questions, please pop those questions into the chat. Myself and some of the Pro Manchester team will be keeping an eye on the chat box and just finding out if people have got questions. I might pull some of you in. So if you want to stick your hand up, if you look in the participants pane, there's an option for you to stick your hand up in there. So if you want us to come to you, ask a question, that'd be absolutely brilliant. So that's great. I just wanted to do a couple of thank yous. First of all, to Appleyard Lees and Electricity Northwest, who have sponsored this morning's event. Obviously, a thank you to all our speakers, and obviously a thanks to the Pro Manchester team for organising this session and putting together such an amazing group of speakers. You'll meet them all. I won't introduce them all now, but you'll meet them as we go through the morning. So that's our plan for today, a good few panel sessions, and don't worry, there will be some breaks. So we'll be stopping for you to replenish those cups of coffee as we go through the morning. Just to get us moving today, obviously the theme is clean tech, green tech, and our race to zero carbon. Race to Zero is the badge that people are putting on this year, organisations, businesses and cities aiming to get to net zero according to the Paris Agreement on climate change. And for me, it's a really, really important thing for us to consider as a city. 2020 was another record breaker in terms of global temperatures. So even though all of us were dealing with the global pandemic, meanwhile, climate change and the climate crisis was continuing. Alongside 2016, it was the warmest year for Europe on record. It's also the year that I was chairing the Manchester Climate Change Partnership, a chair which I've now passed on to Mike Wilton from Arup, who will be doing an amazing job. And I really got to understand how much the city was doing to actually confront the climate crisis. Just a couple of thoughts from me before we get started, but Manchester was one of the first cities to set a science-based target to get to net zero. Our target is 2038, and it's a tough target. It means up to a 15% year-on-year reduction in emissions. So we really, really have to get there and get there fast. And one of the fascinating things about the target that we've set ourselves is that if you look at what today's technology can do and what today's policies can do, there's a gap between what's technically feasible today, where we are now, and where we need to get to by the target we've got, which is 2038. And I always like to think of that gap between what we can do and where we need to get to as being an innovation zone. And that's going to be the theme that we're going to pick up all morning about how businesses, academics, the city itself can innovate and achieve that net zero target. And one thing I feel very strongly about is achieving that target of net zero has to mean what some people call a just transition. Because one of the toughest things I've learned about climate change by the most affluent, but it's in Manchester too, where the very most vulnerable in our society will be the ones to deal this hardest. So we have to achieve this for all of us. It is a case that we have to achieve it because there's a social justice issue embedded in climate change. And again, this may come up during the course of the morning with our speakers, because it's taught us that we can change, that we can transition, that we are vulnerable across the world, and that we need to come together to actually achieve and confront the big challenges that face us. So I think we've learned a lot. Now, here in Manchester, we're in good shape for achieving this transition, I believe. We actually have one of the strongest clusters of green technology companies in the UK, which is amazing, and it's growing. And we have the huge opportunity of the partnerships that this city is so good at. So bringing universities together with business, with third sector, with local communities. We're really, really good at that. It's what's in our DNA. So I think that we can achieve that huge challenge of decoupling economic growth and prosperity from our carbon emissions and getting to net zero by our target of 2038. Now is a good time to be doing it. This is the year of COP26. So in November this year, in Glasgow, the world will be reconvening to see how we're getting on with reaching the stretching targets we set ourselves in Paris 5 years ago. And so the light will be on us, and it's up to cities like Manchester to establish a leadership in that space. We're the first industrial city, and this wouldn't be a Manchester event without a bit of Manchester boosterism. So we defined a lot of the industrial revolution that created climate change. So it's really fitting that we help to solve the problem. And I've said it many times when I've been working on climate change in the city. If we can achieve net zero, as the first industrial city, if we can get to net zero, then no city anywhere in the world can say this is too difficult. So I'm really glad you're with us today. We've got a huge number of people registered and a great set of speakers. And we'll start really unpicking what innovation looks like, where we can get to, and what the future holds for us. So, as I say, it's going to be a good morning. Thanks again to the Pro Manchester team. And we're going to kick off in just a moment with our first keynote. As I said, if you've got questions for our keynote speakers for the panel, or if you've got questions for me, then please just pop them in the chat and we'll keep an eye on it. Our first speaker this morning, I'm really pleased to have as a keynote. Our office is literally about 50 meters from the Graphene Innovation Centre here in Manchester. And graphene obviously has been a huge story for the city and holds immense potential. And I think a lot of people don't realise that there is a profound role for graphene in achieving a sustainable future. So we're really lucky this morning to have the chief exec of what's called Graphene at Manchester. And so that takes in the Graphene Institute, the Graphene Innovation Centre, and the cluster of researchers and developers and spin-out companies that are making the most of graphene, the material for the future that was discovered here in Manchester. So James Baker is with us this morning, our first keynote. I'm going to ask James to switch on his camera, and he's the chief exec of Graphene at Manchester. Over to you, James.
Thank you, and good morning, everybody, and pleasure to be here this morning talking on this sustainability conference. For me, it's a really keen and emerging theme, some real challenges around some of the targets that we've set. But what I'd like to do is just really introduce some of the work. We're not just on graphene, but the broader advanced materials and how that can support this important agenda. So thank you for the introduction. A little bit of history. 2004, two scientists here in Manchester, driven by curiosity, took some sticky tape and some graphite, and you can all do this at home. And if you peel the sticky tape and the graphite, if you peel that sticky tape over and over, approximately 17 times, eventually you can actually isolate a single atomic layer of carbon. So what is graphene? It's got length, it's got breadth, but one atomic layer thick, it's a thinnest possible material. So what, you might say to yourself, they then went on to measure that material, and it had some unique and different properties as a 2D material than that exists as a 3D material, which led to the Nobel Prize in Physics in 2010. So Professors Andrei Geim and Kostya Novoselov were core to that, but today we're not only looking at graphene, we're actually looking at probably over 100 other two-dimensional materials. So what's the interesting bit? As a 2D material, it has these unique properties. You may have heard things like 200 times stronger than steel, firmly electrically conductive, strong, flexible, transparent, can also act as a perfect barrier to either block any molecules passing through or to be size selective to allow some molecules to pass through but to block others. So immediately, not only is that important around great science, but if you think of the many products and applications that could exploit those features, we're talking around opportunities from aerospace to automotive, to energy, to construction, to healthcare. And important with the agenda here today, carbon being sustainable, We've also got the opportunity to look at recycling, reuse, and actually taking existing materials to enhance the properties, to reuse those over and over many times in the future. So great science is taking place, but around 2010, the university also entered dialogue with the city and with the UK government around how can we also take that discovered in Britain into made in Britain and actually create jobs, create supply chain. And again, there's real opportunity for both industry, but new supply chain, existing supply chain, to actually develop these new products and applications based out of Manchester and the UK. So a part of that journey, the university received £61 million for the the National Graphene Institute. So this is just off Oxford Road. It's a £61 million facility. Its purpose is really to accelerate that early stage of discovery, bringing together the physicists with the engineers, with the material scientists, to really accelerate that early stage of discovery. And not only today are we looking at over 100 2D materials, we're now starting to create stacks or heterostructures of layered materials. So effectively you're starting to build into your material functionality. So the world of the future will have these multifunctional materials that are built layer by layer of 2D materials. In addition to the NGI, we also have the Sir Henry Royce Advanced Materials Institute here in Manchester, a further 235 million, not just looking at graphene, but a whole family of advanced materials. We're also part of the £1 billion graphene flagship, still part of that despite Brexit. We're still in year 7 of a 10-year programme, again bringing great science, but also bringing together that supply chain and product and application development. Today, though, I want to focus a little bit more on our second graphene building. We just talked about the Graphene Engineering Innovation Centre, or the GEEC. So this is a second £60 million facility on the old UMIS campus off Sackville Street. And again, this is a £60 million facility, partly built and funded by Masdar out of Abu Dhabi. Masdar, for those who are aware, is a sustainable energy business out of Abu Dhabi. So a key theme, a key drive around supporting the sustainability agenda, and then 30 million from UK government and Europe. So again, 120 million pound on facility, as well as the broader Royce and advanced materials. If I then look broader into Manchester, we have organisations like Salford with the Energy House. So a huge capability here, not just in the University of Manchester, but across the Northwest, and also the Catapults organisation that really bring that great science, that great development and opportunity for products and applications. So the GEEC is more about the translation of that science into products and applications. Anybody who does their history has probably seen that it can take many years from discovery through to a product meeting the marketplace. Carbon fibre is a great example. From discovery through to first products was probably 25 plus years. And then you started to see it appear in aerospace, in Formula One, in sporting goods. So part of our charter, and we call it the Manchester model, is how do we really accelerate that time from discovery through to products and applications in the marketplace. And that's very key around the collaboration and partnership model. The university brings that great science, that great background research. We have the facilities, but what we really want is that collaboration and partnership with industry to create supply chain that creates product and creates application. So the focus of the GEEC is everything from material production. How do we make graphene not by the gram, but by the kilo, by the ton, or by the meter or the kilometer squared? But we don't want to be the supplier of the material. We want to create supply chain. So we're working with partners today who can now make graphene by the ton. They have REACH registration. And for those who are interested, you can now buy graphene at a more affordable price by the ton, by the tens of ton. And there's companies who can provide that at a quality, at a reasonable price, and at a consistent yield. So material production is key. But it's not just graphene. We're looking at a whole range of other 2D materials. The latest going through is a product called MXene, for those who are interested. But really, it's this whole family of 2D materials that can create competitive advantage for the future. The focus of the geek, though, is really around application. So composites is everything from graphene into rubber, through to carbon fiber, through to plastics, through to biomass, for example, that may replace plastic. Some of the other interesting developments, and you'll hear from a speaker later on, is by adding graphene, for example, into recycled rubber, you can re-enhance the properties of that recycled rubber to again get a recyclable product that's got reuse, and rather than scrapping or setting on fire waste tires, you can create value from that waste product. We're also looking at printed electronics, everything from sensors through to wearables. So if you think of smart cities in the future, embedding sensors into clothing or into roads or into structures, again, graphene can play a key role. Energy is everything from batteries to supercapacitors, ability to rapidly charge, discharge an energy source. Again, some real opportunities around sustainable future energy sources using graphene and 2D materials. Membranes and coatings is everything from your anti-corrosion coating, again, quite key if we can extend the life of our buildings or our structures, whether that's a road, a barrier, or a building, through to a membrane, really exciting. Potentially we could take dirty, salty, contaminated water through a graphene membrane to create drinking water. Again, if we could bring local water supply rather than having to pump that around, again, could really transform not just here in Manchester, but around the world in terms of water supply. And core to everything we do is that fundamental science and know-how. So being able to measure and understand at that nanoscale is absolutely core to the capability that exists within the geek and the broader University of Manchester and other universities. So we're talking today about sustainability. So I'd like to just give a few examples of how graphene and 2D materials can support this sustainability agenda. We have aggressive targets of 2038 for Manchester to be net zero. So to do that, we have to be bringing materials along now. We can't afford to wait 5–10 years. We really need to accelerate how these new materials might support these new products, these new applications that meet these net zero targets. So just a couple of examples to talk around is how graphene might support automotive. So everything from batteries to fuel cells I just talked about. A really exciting development there is graphene into batteries. My belief of the future is we'll move more toward a hybrid type structure. So hybrid structure, having a battery or a fuel cell for your range, but you may have a supercapacitor, the ability to rapidly charge, discharge. For example, when you accelerate, then you brake. When you brake, you recharge your supercapacitor. You then use that energy to accelerate. So for buses, for transport in cities, supercapacitors can play a key role. And again, there's some really interesting developments. We're working with partners in that area. Thermal management is all around heat, more efficiency. Can we make our structures both more efficient, but can we also make them lighter and stronger? So lightweighting, whether it's for an aircraft, whether it's for a car or a structure, if we can make a structure lighter, it uses less energy to move it around and potentially less cost to actually manufacture that component in the first point. So again, just looking at automotive as a case study, you can see graphene playing a key role in transport and start to integrate that. Could you actually make your structure into a battery or a fuel cell? So actually your car structure has a secondary use that you store all your energy into that structure. Again, that may make it lighter, give it longer range, and give it higher performance. Another area, just to give some examples, is construction. So this is everything from graphene into, for example, concrete. One of the challenges people often think about is does graphene cost more money to my product or application? But as an example, by adding less than 0.1% graphene into concrete, we believe we can get the equivalent performance for approximately 30 to 50% less concrete material. So that only is a lower material cost because of less concrete needed with a very, very small amount of graphene. It's also a lower CO2 footprint from not only producing the concrete, but also the supply chain of getting concrete to the building site or to the road actually reduces that cycle time. But also we can probably improve the cure time to get the concrete to cure or the road to cure in a shorter period of time. So again, by doing a quick case study, you see how graphene might contribute in construction or roads to reduction in CO2 in a more sustainable area. We're also working, for example, with Highways England. We're looking about putting graphene into roads. If we can make the roads less, more durable, but less prone to damage, so less potholes, that will be less repair, more productivity through our roads, less maintenance potentially by putting graphene onto the barriers, so anti-corrosion, through to sensors into the road to actually understand traffic flow and then smarter roads in the future. So again, some very interesting work looking around how we incorporate graphene and 2D materials into construction. Again, another good case study. So what's critical to making this happen? Innovation, as I said earlier, can take many years from the lab through to the marketplace. We can't afford to wait 25 years to have some of these products in the marketplace. We need to work differently now. So what we've developed in Manchester, it's not new, but for me it's quite unique as part of a university, is this problem-led model in the geek. Industry comes along with a challenge, with a problem. I want to make my road stronger. I want to make it less potholes. I want to make my barriers last longer. I need my car to be lighter weight, to be stronger, to use less fuel. So what is the problem we're trying to solve? So it's a challenge-led organization. We then bring together the smart people from the university, from the supply chain, from the engineers, from our businesses. We come up with a design. We can then very rapidly make a concept or a prototype, adding a small amount of graphene into concrete or into a rubber or into a composite. We quickly make a component. Does that work? Does it improve the performance, make or break? If it fails, fail fast and learn and move on. But how do we really iterate that whole cycle many times to bring these products to market? And already we're starting to see some real examples of graphene in the marketplace. I'll just mention a few, going back to cars. We're working with a company called BAC Mono in Liverpool, who are putting graphene into composite. Ford out of the US put graphene into a foam in their engine bay. We estimate over 1 million cars are on the road today with graphene in the foam. It's both lighter, more thermally management. It also reduces noise and vibration, and it's also flame retardant, just to give you some examples. If I look at rubber, you'll be hearing the speaker later, who's putting graphene into recycled tires to make rubber mats and other rubber products. Today, you can actually buy a training shoe for any runners out there, putting graphene into rubber to make the rubber both soft and grippy, but also more durable. Again, supporting sustainability, less scrap shoes on the scrap heap because they last longer because they're more durable. So this model is quite key, and we're working with many industries, over 150 industries to date we are working with, from large corporations to small corporations. A little plug for, we're in Greater Manchester today. We have a program called Bridging the Gap that's specifically aimed at working with those small, medium enterprises out of Greater Manchester, whether you're an existing business or a startup or a spin out. We work with a whole series of micro SMEs through to established businesses, where graphene by adding graphene might improve your performance of your product line, or it might improve new products that you can then take to market to improve your product offer into the marketplace. So again, if people are keen to do that, happy to speak to both large but also small businesses. And again, there's some contact details there. So finally, just to sum that all up, for me, what we're really trying to do, if you look at this chart, for anyone who's involved in technology development, bottom left of the technology readiness level, the scale developed by NASA, blue sky research typically starts on the bottom left of this chart. So technology readiness level 1, but at that stage it's blue sky research, it's fairly fundamental, we haven't got all the answers. To get a product in the marketplace, we want to be in the top right hand of this curve. And typically we go along the TRL scale, and then we slowly go up the system readiness level. For those who are aware, system readiness level includes manufacturing readiness level, commercial readiness level, certification, end of life, health and safety, all the other things we have to consider if we're going to take a product to marketplace. So we have the university, not just Manchester, Salford, MMU. So we have that fundamental science and know-how. Through the National Graphene Institute and the Royce, we're really looking to extend that science into concepts, into ideas, addressing some of the other areas that needed to be addressed if you take a product to market. The geek is in that valley of death, that rapid make or break, and core to that is collaboration with industry. So just to summarize, what we're really trying to create here, sort of copied from Silicon Valley, is we are trying to create this ecosystem of what we call Graphene City. But one thing that's coming very clear, and particularly with the agenda here today, Graphene City can also support the support of a green city. Thank you for listening, and happy to take any questions if people have any questions they'd like to raise. Thank you.
Thanks, James. That's great. I'm going to kick us off with a question, if that's all right, which usefully picks up on that last slide of yours. We're currently behind the curve in terms of reducing our emissions year on year. So we've got room to make up. And I always think with something this challenging, you need to work harder and harder and harder and never rest on your laurels. How can the city work harder with you to achieve that sort of graphene city idea of a living lab where graphene gets deployed? What more can be done to make this happen?
So I've talked quite a lot about the technology side, but the final slide I used had this second curve, which I call system readiness level. Often new materials are seen as risk. So we do the work in the science lab, we do the work, but there's still a big gap between that and having a certified product we can take into the marketplace. So this system readiness level, the certification, the regulation, the de-risking, if you like, is critical to go to the market. So what I'd like to see, and we're already talking to partners like Highways England, but also with companies like Arcadis, if we can actually do some, I call it risk reduction. So the geek will make product by the kilo or the tens of kilo. Example of that is we're working with a company in Greater Manchester around putting graphene into concrete. We now need to lay a floor of a building using that graphene enhanced concrete. So we're planning to do that hopefully this year. It's not going to be a skyscraper, that would be high risk. It's probably going to be a smaller warehouse. But if we can actually start working with the city and key players in the city, whether it's a house, whether it's a road, whether it's a structure, start relatively low risk. I wouldn't do Mancunian Way as the first road, but I might do Sackville Street, but still got a good traffic flow. So as well as getting that technology data, we need the engineering and the qualification data that the road doesn't break up, it does work, and we get real data that will then de-risk to actually adopt that technology in the future. So really keen to embrace both the end users, but also the supply chain about bringing this together in a much more accelerated way. I'm not saying just chuck graphene in and chuck it on the road. We'll have data, we'll have test data, but once we've got some good data, see how we then rapidly experiment and take that into low risk applications to reduce the overall risk. For me, that will accelerate the adoption of these new technologies into the marketplace, which will be critical.
Thanks, James. That's great. Just one last question from one of our participants was actually about the sound properties of graphene. They've got a very practical question about whether it can be used to reduce sound for screens that they manufacture. Is that a property that's been explored?
Yeah, so I touched a little bit on Ford. So again, think of graphene as an additive. One of the challenges I haven't spent much time on today is graphene as a single layer 200 times stronger than steel. It's not practical to use at that level. It's too small, you need a microscope, you can't use it. But when you add graphene to a foam as an example, using the Ford example, Ford actually started looking at graphene for mechanical strength, adding into the foam to reduce the weight and the thermal efficiency of the engine packing. An unexpected byproduct was that noise reduction. And if I look at automotive, as we move to more electric aircraft, clearly noise reduction is critical. So by adding graphene to a foam, can you tune that graphene so that it also reduces noise? Again, some good science there. There's some more evidence depending on the foam. It doesn't work in all occurrences. So again, I'd encourage the company to look at it. Can we add graphene to an existing foam to see if that would improve not just the noise reduction, but also, for example, flame retardant and maybe thermal management. I was watching an interesting program on new houses last night where someone used soil effectively to keep heat. Could we have a foam that also manages that heat within the structure? Again, talk to us and we'll have a discussion.
Brilliant. Thanks ever so much, James. That was a good question from John Blaskley there. We've got a question in the chat from Marcel Ridyard from AFL Architects, but we haven't got time to tackle it. So, James, could I ask you a favour of you or one of your colleagues to just post a response to that in the chat, if that's okay, while we move on to the next?
I will do, no problem. Thank you.
Brilliant. Thanks ever so much. Oh, well, last thing, where do I get my graphene running shoes? I'm excited.
So you can buy them The shops in Manchester sell them, or online. You may have seen the brand. Yeah, innovate. Yeah, they're fail running shoes, but again,
I did notice a cheeky swoosh in there. Yeah. Oh, there we go.
Colours, props. I mean, didn't do the prop today. You can even buy graphene masks for those who are into graphene. So again, a graphene mask. So products are on the marketplace today.
Brilliant, amazing. Thanks ever so much, James. Really, really great. Okay, I'm going to move us on now to our next session, which is a panel session all about green advances in our homes and what impact innovation can have in terms of getting us to net zero in our homes. Now, buildings account for way the largest area of direct emissions on carbon. And so the next two panel sessions, we're first of all going to look at residential properties, and then we're going to focus on commercial buildings. So I'm going to ask the first panel to switch on their cameras. We've got Daniel Burton from Wondrwall. We've got Will Ennett from TalkTalk, their head of sustainability, and we've got Will Swann from the University of Salford. And what I'm going to do for this is I'm going to ask each of them in turn to just give us 2 or 3 minutes, and I'll be quite strict on time, 2 or 3 minutes to just outline what they're doing in this space. And then we'll open up for some questions and discussion in this session about what all of this means for our homes. So without further ado, I'm going to ask Daniel Burton from Wondrwall to give us 2 or 3 minutes on what Wondrwall is and how it's making a difference to our homes. Daniel, over to you.
Thank you, appreciate that. Yeah, so Wondrwall, obviously a Manchester-based technology company. We started out in 2015. Funny enough, we actually started out primarily as a home automation business, but a home automation business based on intelligence. We invented the most advanced light switch in the world, where we put 13 sensors into a light switch. So in a home, we put about 130 sensors in a home. We learn how people live and behave within their home. More importantly, how that home performs, so how it heats up, how it cools down, the thermal model of that building. And then obviously with all that data, we control the home. So we control all aspects of heating, lighting, security, safety. We've got Alexa built into every light switch. We're fully integrated with Sonos as a music system. So we launched that technology into the market back in 2018. And the majority of our customers were house builders. And we said to them, what's going to be your issues going forward? And obviously climate change and decarbonisation, the big issue for house builders was actually not being able to use gas past 2025. So as a company, we said we will go and develop an all-electric solution for you. So we developed 2 different types of heating technology, infrared heating panels and electric underfloor heating. But it was actually the way that we controlled them that made them a lot more intelligent. Normally a home will heat up every room in a home, but what we do within the home, we use the data to actually learn about what rooms you spend time in. So if you wake up in the morning and you go from your bedroom to your bathroom, you get changed and you walk out the front door, the home will know what rooms you spend time in and only heat up the rooms that you spend time in based on that data. So we reduce energy consumption by about 50% by intelligently controlling the home. Then we developed a hot water cylinder, which learns about how much water you're going to use within the home. And instead of heating up 200 litres of water, it will learn about the flow of water. And if you use 30 litres of water in a shower in the morning, it will heat up the amount of water you need rather than heating up a full cylinder. The next step was to create net zero homes. We believe every home should be sustainable, create its own energy, store its own energy, and use its own energy. So we developed some battery technology, one of the biggest battery companies in the world, 6.5 kilowatt residential battery, inverter, and then we put solar on the roof. So what you have then is a home that creates its own energy, stores its own energy. And where Wondrwall completely different globally is having the intelligence within the home to control them energy assets. So my home will download the weather data for tomorrow. It will calculate how much energy my solar is going to generate. And if I need to take some energy off the grid, my home will dial into an energy company and bring in a time of use tariff, which gives us the ability to buy energy every 30 minutes during the day. So 48 different tariffs, and that can range from minus 12 pence to 30 pence. So the home will make a decision of when to charge that battery up at 2 o'clock in the morning. Energy is at 4 pence a kilowatt, we'll charge our battery up. And then the home is either going to use free energy from the solar or very, very cheap energy off the grid at certain times. And obviously the home can also sell energy back to the grid. If you're away on holiday, it will still do the same process, but work out the most optimum time to sell energy back to the grid. And we're reducing energy consumption by, on average, the average home is around £1,300 a year. And we're reducing that energy bill down to around £100, £150. And that's only normally just because of the standing charge, if you will. So it just gives you a brief overview of what Wondrwall does as a company.
Brilliant, Daniel, that's absolutely spot on. And it's so amazing to have a Manchester company doing such brilliant work. It's really exciting, exactly what we need to see. Okay, I'm going to turn next, and I'll come back to you in a minute, Daniel. I'm going to turn next to Will from TalkTalk. And I know, Will, you are going to touch on our homes and the difference that you can make there, but also implications for commercial property as well. So, Will, if you'd like to do your 2 to 3 minutes intro.
Yeah, thanks, Steve. Yeah, so TalkTalk is a connectivity provider, and we have a Northwest head office in Salford. And, you know, we're obviously quite well known in the UK for residential connectivity, so residential broadband customers. However, we also have a thriving business arm, so providing businesses with connectivity services. So that's our bread and butter. And the exciting thing within the industry is the move to full fibre, or fibre to the premise, as it's often called. And that, I think, has some really potentially great implementations in terms of how we decarbonize as a UK. So first and foremost, what we've noticed is the actual network itself is much more efficient. So by our own internal research, about 80% less energy consumption than our traditional copper infrastructure that's used in the UK. It can also obviously support things like home working, and you know, obviously we've seen in the last year a dramatic increase in that, but all the while the actual let's call it carbon emissions and energy consumption that the networks used in that time continue to decrease. So there's clearly a big opportunity there, and then also the other nascent opportunity, which we're still learning about, is IoT. So, you know, to what extent can we help, I guess, facilitate some of the great work that the other panelists are doing in terms of using, you know, connectivity to transform the energy consumption and carbon emissions of the home. But also, you know, potentially there are ways that we can augment, you know, the data we have and some of the expertise we have. And so that's a conversation, I think, for the future.
Brilliant, thanks, Will. That's an excellent intro to TalkTalk and what you're doing. You were glitchy at the minute there. I think you probably had some homeschooling going on while some homeworking, and I think you maxed out your broadband, which is kind of ironic. So, but you came back strong in the second half. So thanks ever so much for that.
If there's any bit that that was missed, I'm happy just to recap.
Yeah, we'll come back to you in a minute. I think you started when we were turning to IoT, which for those of you who don't know is the Internet of Things. We missed a little bit there, so I might come back to you on that if that's okay in questions. But I was just going to turn finally for this panel to Will Swann from the University of Salford, a man who likes to put ordinary houses into laboratories. So, Will, can we come to you, please?
Yeah, sure. My name is Will Swann. I'm a director of Energy House Labs at the University of Salford. And as Steve said, we're famous for having a whole house in a climate controlled lab. So about 10 years ago, we built the Salford Energy House, and it's been fairly fully booked ever since. I think if you wanted to test a product in there now, it's sometime in late summer. So where we work is anything to do with energy and residential. So we're talking about insulation, doors, windows, loft insulation, heating systems. And over the last 4 or 5 years, and particularly the last 3 years, we have engaged in smart meters and IoT. So we built a smart meters lab and launched that in 2018, 2019, which has SMETS 1 and 2, but also an IoT device, an IoT infrastructure in there. So we're pulling data off it and engaged in connectivity. Our big project at the moment is taking the original Salford Energy House concept and writing it large. We're building probably one of the biggest environmental chambers in Europe, and that will have the capacity to test whole houses. So the original Salford Energy House was a Victorian end terrace and half a next door house, where we looked really at testing retrofit products. But what we're seeing now is, you know, lots of offsite manufacture, new ways of building to get to that zero carbon goal. So we put ourselves in a position whereby from early 2022, we will be able to test whole houses. And as part of that program as well, obviously we've got very similar to the Graphene Centre, we have an SME support service as well at the moment to support people, you know, in those spaces around IoT and energy efficiency products. And just, I suppose what we're seeing, I don't know, some people may not remember, we should have been zero carbon homes in 2016, and that was abandoned. what we're seeing now, probably more than then, is the industry taking this very seriously. I think the volume house builders, certainly social housing, insulation manufacturers, they're all taking this zero carbon objective much more seriously than was the case maybe 5 or 6 years ago. And I think they see that it's not going to get lobbied away now. So that's, renewables, storage, IoT, and then much better construction, highly insulated properties, and understanding actually how those properties perform, not just in terms of energy efficiency, but also indoor environment as well. So, about comfort, about ventilation, about air quality. So there's a lot of things going on in the space at the moment, Steve. It's a very exciting time to be working in the field, to be honest.
Brilliant, thanks, Will. That's excellent. I'm just going to stay with you for a moment, Will, and obviously you bridge the gap between new build and the whole retrofit agenda. And as we know, 80% of our buildings today will still be standing in 2050. So retrofit's a huge issue for us. If you had to pick sort of one really critical area of innovation that's needed to accelerate retrofit, what would you center on?
I would actually say a better understanding of the market and some better financial models. I think technically, although there are issues around skills and quality, there will always be issues around that in the construction industry. It's actually how do people access this? And I think we saw in The Guardian yesterday, there are issues with the Green Homes Grant a little bit at the moment. So actually, how do we have that innovation? So there's a piece of work that's just in GM, and I think it will be very shortly public, to understand what owner-occupiers think about retrofit. So rather than foisting a technical solution on them, help them understand that actually the different types of benefits that it can bring. And I think that really is about business models. That really is about business models and financing.
Brilliant. Thanks, Will. That's excellent. Will Ennett, rather than Will Swann, I promised to come back to you. I think one area that's really interesting is the Internet of Things. We had a program here in Manchester called CityVerve that started to look at the impact IoT could have on the city. Could you expand a little bit on, for you, where you think IoT takes us in terms of sustainability in our homes and more widely in our buildings?
Yeah, sure. I mean, I would say, being very honest, obviously, it's still a nascent area for us, and the underlying element, as I mentioned before, is that stronger and better connectivity that full fiber or fiber to the premise can allow and can bring. And actually, it was quite interesting as well last year as the Committee on Climate Change, also advocated advocated the government to maybe divert some of that road infrastructure investment towards the broadband infrastructure, because that can both, lift up the economy as well as, being a much, less carbon intensive way of growing the economy. So I think that remains probably the baseline, and that will then, I guess, create a scenario where all of that can really exist. And my home, embarrassingly being a case in point, I don't have full fiber, maybe had a glitch. So that's probably the first layer. And then I think on the second layer, we are starting the conversations. I would love to hear from more people. So probably an open invitation as well to talk to more people, because we do have quite a lot of data. Daniel, for example, in his panel obviously suggested really some quite great and phenomenal data capture, but we also obviously have data on number of devices, how people connect, when they connect, and I'm sure that within the realms of what's possible, there might be some exciting partnerships we could strike.
Brilliant. Thanks, Will. I'm just going to turn to you, Daniel, if that's okay. On that last point that Will brought up, which is data, and in particular the last 12 months where our homes have become our offices largely, and we're using Will's infrastructure to be able to carry on working. You must have an incredible amount of data at Wondrwall about how we use our homes, how we power our homes. And so I'd really love to hear, I'm sure we'd love to hear more about that sort of data that you're using to intelligently design these systems. And also, because you've been on this journey from the sort of light switches through to the energy systems, I'd just love to know, where are you going next? What's your next area of innovation that Wondrwall's really looking at? So over to you, Daniel.
Yeah, so starting off from a data perspective, we have about 20,000 data points a day on a property. Where we have really focused on adding value is we do a lot of work for housing associations and councils. So talking about whole house retrofits, we undergo whole house retrofits where we remove gas, we will insulate, and then we'll fit a Wondrwall net zero solution. But what that gives the housing associations ability to do is digitalize their estate. So they can monitor the usage within their estate, they can monitor occupation, they can monitor energy usage, they can monitor the thermal model of that building. And they can also pick up from a maintenance perspective, actually, if a device goes down, they can build their maintenance around the data that's being collected. So that's from a digitalizing a housing estate, is that you can make better decisions with the data that's coming in. We also do quite large build to rent schemes. So we do 155 apartments where we put 16,000 sensors into a building. So that building in itself becomes quite an intelligent building, because from a sustainability perspective, you know how many lights it's turning off when people are leaving the home, how many heaters it's turning off, occupation, all of this. So actually from a global view, the building can say, okay, we're saving this amount of energy on a daily basis by making intelligent decisions of turning heating off and turning lights off when people aren't in their homes. If we talk about actually what's next for us, we're just integrating EV chargers, so developing EV chargers to integrate EV chargers. But obviously, with the intelligence within the home, and obviously the information that we're taking from the smart meter, and obviously the energy companies, we can actually work out the most optimum time to charge up vehicles. So if you plug your car in, well, actually the home's not going to turn it on straight away. It's going to work out the most optimum time to charge that car. So at 2 o'clock in the morning, when energy drops in prices and we're tracking the wholesale cost, we'll start charging a vehicle up, if you will. So yeah, that just gives you a brief overview of what we're doing.
Brilliant, thanks, Daniel. And sorry, this is a shameless plug. So, and I'm doing it for you, so you don't need to feel embarrassed. But I did have a little shufti around your website, and there's a whole bunch of packages. This isn't some kind of special deal. I mean, anybody can look at Wondrwall and start the journey towards retrofitting into their homes today, can't they?
Yeah, and it's completely modularized. So at the end of the day, you've got home automation, you've got heating systems, you've got hot water, you've got battery and solar, and you can take whatever you want from that system. And obviously it is all based on intelligence, but you can take whatever. On average, for a standard home, if you're talking a full home automation system, heating, hot water, battery, solar, built into the roof, it's around £10,000 as a full solution, if you will.
Brilliant, thanks. I said it's a shameless plug, but I did it, so it's okay.
Appreciate
it. Well, Swann, I want to come back to you. And first of all, on that, you mentioned the sort of the retrofit challenge and the challenge of homeowners and financing. And we're going to pick that up. We've got a financing panel later today that will look at that. But I wanted to come back to you, and I'm retrofitting my home actually. I've escaped for the day into the office, and there's just carnage back at the house.
Who's doing it for you?
It's ground source. Well, it's a ground source heat pump. It's the biggest mess you've ever seen in your life. I wanted to ask you about is there some way in which you are actually bringing homeowners and occupiers into the mix with the energy house, so that it's not just, I mean, important though it is, talking to innovators and business and house builders, but are you using it to actually look at how ordinary folk like me live in their homes?
So, I mean, what we do is we do a lot of outreach. So we do outreach to schools, we do a lot of media. You know, we were doing Sky News over Christmas, the gadget show and things like that, because actually the thing is having real evidence. For us, that's really what we're all about. What works? If you shut your curtains, how much energy does that save you? If you have a carpet instead of floorboards, how much energy does that save you? So really for us, and it, you know, it's getting easier all the time because of the things that Daniel and Will are doing. You know, we have lots and lots of data. So that's how we outreach to the owner occupiers and to the public, which is to say, look, this works. This works this well in this case. And I think that's really where we will get an adoption of retrofit, when people understand what benefits it can bring, not just being told, but being shown and having it demonstrated. And I think this will, you know, Energy House 2 will allow us to do that again in a much bigger way. So for us, really, the more evidence we can get out there and the more we can show people the benefits of improving their homes, the better, really. I think that's really where we see our role, working with businesses, but also putting that information out there.
That's great. Thanks. Well, yeah, I'm really conscious that even if we were to get the finances right and the model right and the technology right, there is that messy human in the mix that we need to convince. Brilliant. Just one more thing, Will, while I'm with you, going back to sort of graphene and the graphene city and advanced materials. Is there any way, I know it's a different university, but you guys talk together, I know that much. Is graphene playing a part in Energy House too?
Well, we're actually talking with James at the moment about building materials. So for us, really, we're further down the TRL level. So we get involved with product manufacturers. And I think there's another initiative actually where we're trying to bring the 3 universities together called the Energy Innovation Agency. And that is really about working with businesses to help, rapidly move their products through all of the fantastic innovation infrastructure that's available in Greater Manchester. So from my point of view, a graphene product can go into, be developed and then come into and be tested at system level in Salford, from Manchester to Salford. Or a graphene fuel cell can be developed at Manchester and then go over to MMU and then come to Salford. And we're trying to make it a lot more seamless, because I think it's such a big problem. It's not well served by being parochial and looking inward.
Brilliant. Thanks, Will. Well, Ennett, coming back to you just to round us off for this panel, and then we're going to move on to commercial property. I know from having a chat previously before the session that TalkTalk as a business is busy setting a stretching target on carbon and adopting the race to zero. And I just wondered whether you could, it's not necessarily about our homes, but talk about the corporate challenge for large businesses like yourself, particularly in this COP26 year, about what big businesses can be doing.
Sure. Yeah. No. Thank you, Steve. So, as I mentioned previously, I think the network or the telecoms industry is in a relatively good position in that we're maybe not the largest emitter of carbon, but nevertheless, all of us are making strides. And in the last 5 years, we've managed to make our operations, or what's called scope 1 and 2 in the kind of carbon reporting lingo, we've reduced that by 63% in the last 5 years, consolidating a lot of our office spaces, but also innovation in our data centers, which is our largest energy footprint. And our offices, our head office in Salford and all our other properties are now run on green electricity as well. So that's been what we've been doing. And as you said, Steve, we are aligned to what's called Race to Zero, and we're setting science-based targets. And the challenge there is, as you expand the scope into your indirect impact as a business, so both your supply chain and then onto your customers using your equipment. And that's probably where we tally in with the domestic home, because now we really have to be conscious of the energy consumption of our routers, our set-top boxes, our mobile phones, and any other devices we sell. I think what's interesting there is that's obviously for us it's important, and it's a big component of how we transform our business. But in the home overall, it's a relatively small percentage of energy usage, and and how the domestic home decarbonizes. So I still think the opportunity for us is, rather than just our own business, but how we can almost help other industries. So how can we help aid the decarbonization, retrofitting, reducing commuting, and all those other things? That's probably where we can have the biggest impact, I think, on UK's decarbonisation, and obviously Manchester's 2038 goal.
Brilliant. Thanks, Will. That's excellent. I'm going to wrap up our panel now. We've got one of those weird Zoom event moments where you deserve a round of applause, but you're not going to get a round of applause. So if you imagine a huge crowd whooping and clapping, that's what's happening right now in about 100 homes. So there you go. It's a round of applause. Thanks ever so much. And I'm going to move us on to our next panel, which is where we're moving on to the, thanks ever so much, the commercial property sector. So we've got, if I could ask them to switch on their cameras, Alex Edwards from Bruntwood. We've got Jen Johnson from Thermatic, Simon Clouston from WSP, and Myles Kitcher from Peel. So we've got a brilliant panel for you now. And similar format. I'm going to ask each of you just for 2 or 3 minutes to outline your area of business, what the innovation is that's happening there, and if you can, the implications it might have for Manchester. So, Alex, can I start with you from Bruntwood's perspective? If I switch to you.
Yeah, good morning. My name is Alex Edwards from Bruntwood. Probably most people on this call probably know a bit about Bruntwood, but we're a large property developer and landlord, predominantly in the north of England, with huge amounts of commercial office space. And many of you may also know that we've made significant commitments regarding sustainability and net zero. And I've been involved in sort of translating those commitments into practice. And what that means is I'm sort of working on producing internal guidance documents, looking at external guidance documents like UKGBC, LETI, etc. And we're working on making incremental improvements on our buildings to get to sort of what's called Paris-proof targets. And you know, through that journey, I think you've had huge amounts of knowledge, learning right across the business, and particularly embodied carbon, which I think up until a couple more recently wasn't really understood. And I guess the challenge is trying to get my colleagues right across the business to pick it up, rather than, you know, just a few people in the centre trying to drive it. And I guess that's trying to make things, translating it into simple terms. I think you know, some of the challenges which we face as a business is certainly embodied carbon. There's huge amounts of carbon associated with the construction of buildings, and particularly buildings of height where you're using concrete and steel, which may lead to innovation. You know, I think, you know, we've talked about graphene on today, but also use of wood and possibly glue lamp beams. And I think the other challenge is the deep retrofit of existing stock. I'd say it's relatively easy to make new buildings net zero operational carbon, but making existing buildings is probably a bigger challenge. And we're currently running a couple of sustainability pilot schemes on buildings to see, you know, exactly what it's going to take to make those buildings operationally net zero. I've also been heavily involved in a solar rollout across the business, which has, you know, presented a number of different challenges. You know, the business model for a commercial landlord, looking at roof condition, where you've got fiscal meters, etc., etc.
Thanks, Alex. Brilliant intro. Could I next turn to Jen from Thermatic? Jen Johnson, are you there?
Hi, Steve. Yeah. So I'm from Thermatic. I actually am MD of the Energy Services Division, but I work very, very closely with our technical facilities side, and also our Thermatic Homes, which is social housing. And really kind of what I've come to push today is how we need to have a really joined up view between how we approach our HVAC and how we approach our energy management. And it sounds so simple that we should be looking at that together. But you know, we support over 7,000 sites across the UK, and mostly within like the retail industry. And again, there's decisions being made on the HVAC side, which are totally different to those being made on the energy side. And bringing that together is pretty much fundamentally what we do as a business. And really what we're trying to do is, when we've got feet on the ground, we've got engineers on sites, we're looking for opportunity there and then. If we're upgraded, say we're repairing something that's failed, why are we repairing it? How are we repairing it? If we spend a little bit more, what benefit would that give to the client? And it's really like pulling that apart for each of these like reactive HVAC service visits, and making sure we're getting the most out of the visits that we have on site. Ultimately, as Alex is saying, it's so easy to go and say, right, let's start from scratch, brand new building. But we're often working with estates that have been perhaps 20, 30 years old. They've had system put on system, and then a bit of an energy saving device and something else to something over there. And it becomes an absolute quagmire for the client, because they go, Well, I don't know. My lights kind of go on and off as they might do, but sometimes they don't. And we really focus on bringing that together. Whether that's with like a bit more of a heavy duty install, something to do with like BMS, but more so we're really investing in the IoT sector and how we can use that with wireless relays, wireless technology. Again, really low cost solutions that's going to bring together existing technology that's on the site.
Brilliant, thanks, Jen. Perfect intro. And next, I'm going to go to Simon from WSP. Simon, over to you.
Thanks, Steve. Hi, I'm Simon Clouston from WSP. We're a large engineering, planning, environmental consultancy, about 800 people based in Manchester. I think Manchester's in our top 5 of kind of global offices, so plenty of local resource and expertise in this city region. We work across a range of sectors, and in buildings we work all the way through from planning, design and operation. But where I work and what I was going to concentrate on is existing commercial buildings, because I tend to work with portfolios of existing buildings. And just maybe a couple of things to sort of underscore the importance of that. I think Steve commented earlier that buildings are responsible for a lot of global carbon emissions. In total, that's around about 40% across all buildings globally, a combination of commercial and residential. About 10% of that is in the construction, so the point that Alex was making about embodied carbon, but about 30% of all global emissions are still down to how we use and operate, live in, work in, shop in, the kind of buildings that we have. What I suppose wanted to talk about, because in conversations I have sort of around this, I'm maybe not sure that the message is fully kind of getting through yet, that as well as the policy that's coming down the track, in fact, partly because of the policy that's coming down the track, the people who invest in commercial property and real estate for the long term have already decided that commercial property needs to go net zero. The language that they are using is that if any of the buildings that they currently own and are invested in are not net zero or don't have a clear pathway to become net zero within the next 10 to 15 years, they will be stranded assets, and they will regard them as a stranded asset from an investment point of view. And they're increasingly putting in place roadmaps. In the UK, one of the I suppose industry sector organisations we have is the Better Buildings Partnership. Around about 30 of the leading property firms in the UK, in fact, including I think both Bruntwood and Peel, are members of that. And 25 to 30 of the majority of them are in the process of publishing their net zero carbon roadmaps, where they're all committing to net zero carbon commercial real estate portfolios. And they're tending to set targets for 2030. And just as a sort of range of ambition, they're tending to set targets in the range of 50 to 60% reduction in energy demand and associated carbon emissions by 2030, so this next decade. So really significant action being planned in the next kind of 5 to 10 years. In terms of where that's going to come through, maybe just 3 or 4 comments from an existing point of view on, I think, what that means from technology, and very quick comments on some of the gaps.
Be quick, Simon, be quick.
I will. Right, okay. So monitoring and metering is still poor across the large majority of commercial real estate, not adequate to help them really understand what needs to be done with buildings. The electrification of heat, I believe that, and this is certainly what they're planning for, is heat is going electric within buildings. On-site generation and storage, which I know has been touched on by speakers in terms of residential. And the final one I'll mention, because it's arguably the one where I see the biggest challenge at the moment, is improving, how do you improve the fabric performance of existing buildings and do that in a way that's effective and cost effective and is acceptable from an aesthetic point of view and doesn't reduce the usable space within the building kind of too significantly. So 3 or 4 areas of opportunity and challenge.
Brilliant. And I think we'll come back to a couple of those in a minute, if that's okay.
Yeah.
I'm bringing Myles from Peel. You mentioned Peel there as being a leader in this space. Myles, can I come to you?
Yeah, thank you much. Good morning to everyone. I'm Myles Kitcher. I'm Managing Director of Peel NRE, part of the Peel LNP group. Just across the group, like many developers, just echoing what Simon says, when it comes to investors now, high up on their agenda, probably the first thing they're asking about is ESG and low carbon. So it's a fundamental part of commercial real estate going forward, but really embedded in the future. Like many developers, we've got a 5-year sustainability plan. We've managed to get 17 of our properties zero carbon certified, and that's a key feature of going forward. My bit of the business is more to do with providing energy and circular economy type solutions for developments of both industry and commercial. So we're looking at things around local networks and local energy networks, whether it be electricity, whether it be low carbon electricity, or whether it be heat. So we're looking at district heating, whether it be hydrogen solutions, and for industry, looking at carbon capture and storage, and finding a lot of it's transitional technology. We've heard earlier about some very high-tech solutions, but we also need to do some very short-term changes, and some of that is transitional. So one of the examples is working with a company called Powerhouse Energy on converting plastics to hydrogen. Now we need to sort of move away from that plastic economy, but that's tens of years away from. So let's try and help provide a fuel that help decarbonise buildings, industry, and transportation. So we're looking at a lot of solutions, both for our current built estate, but also on new developments. So bringing recycled products. We heard again about not just operational net zero, but actual total net zero. So looking at recycling building products across a range of technologies. So that's a sort of brief introduction.
Brilliant, thanks, Myles. And you win for being the first person to mention hydrogen. We made it to 10:35 on green innovation, and you're the first one, so bingo, well done. I'm going to turn first of all to you, Jen, if that's okay, because I noticed you nodding vigorously when Simon was talking about the poor data, how we understand buildings, what's going on. And I'd wondered if you could pick up on that from Simon and the challenges set out there, but also going back to that earlier theme, is there something we can do as a city to help understand our buildings better?
I think one of the things that we find is that people often say, oh, we want to save energy, and you want to approach something, but they can't get hold of data. They don't really know. And probably like many others, we don't like to just pick out ROIs off the top of our head to say, yeah, you'll get this back. We really want to know what's being consumed and put the facts behind that. And there is really a lot of issue with getting that visibility. And I think sometimes people don't understand what they can get from the suppliers, how they can actually get that data, in what different forms they can get that. And especially when we're working with smaller clients, they can get a lot of information that doesn't cost them anything to get. They're just not aware of the process. So I think there's a big piece to be done about educating people about what data's held, where, and then obviously if they've got the funds to look at sub-metering and additional metering, fantastic. If they can put data loggers in, great. But even just getting clarity on the main supply meters for a lot of the buildings is pretty hard work. How that can affect the city? Well, really, I think we all need to know what we're using. We need to know what we're doing to know how to change that. That's the fundamental of most projects you start with, like, where are you right now? And without that data, you don't know, so you don't know how to plan. We work with a lot of clients where significant savings in their energy can be made through tweaks to their existing systems. We just need to know what's going on. I work with a large client in the northeast, and one of the things they had huge gas consumption in the middle of the night, and someone had just switched a clock and nobody knew, no one was in the building, and without that energy data it would have cost quite a lot of money to have someone sat there all night waiting for things to happen. And that was really the main reason we got to pick that up, and the cost of that was the manager walking in, making a couple of changes on a controller the next morning, nothing, and it made a significant difference. So yeah, I think getting that data and getting that visibility is absolutely key.
Brilliant. Thanks, Jen. Okay, I'm going to turn, this is a joint question for Simon and Alex. Picking up Simon's challenge around stranded assets, which I thought was really interesting. And Myles, I'm sure you'll have a view because you're really over this as well. But Alex, I know this isn't Bruntwood, but are there buildings going up in the middle of Manchester now, which we're going to have to retrofit in a couple of years' time? And if so, why? Are they the very stranded assets that I can see on the skyline here from the office that Simon's talking about? And do we need a very rapid, I mean, instant change across the city? I'm not labeling that at Bruntwood because I know you're doing great work, but there are others at play here. So I just wondered whether you've got any thoughts on that.
Yeah, I think there are. I think the challenge is that a lot of people right across the industry don't really understand exactly what it takes to make a net zero building, and even what that means, because I think that the definition of net zero means different things to different people. You know, some people are quite happy to offset, whereas really that should be a bit of a last resort. You know, a lot of buildings are still going in with gas heating systems, and you know that's certainly in my mind not aligned with net zero. You know, the electrification of heat, as Simon mentioned, is absolutely key to that. You know, we in the most recent developments we've been looking at, we sort of made a bit of a carpet ban on gas going into our buildings and looking at heat pumps. I think that there's other things to consider. So, you know, there's been a real most buildings going up at the moment are probably fully mechanically ventilated. I think a lot of the sort of guidance at the moment is around mixed mode ventilation systems, and you've just put in a facade that, you know, probably lasts, you know, 40, 50 years, and you've not got the ability to utilize natural ventilation.
Thanks, Alice. That's great. Simon, can I come to you on that point as well? And then also picking up a comment in the chat from Marcel Ridyard around examples where what's seen as green actions might actually increase energy usage, probably because we don't have the right data that Jen was talking about. So Simon, over to you.
Yeah, well, maybe if I just start with that one, I think particularly because of what we're currently going through in terms of COVID, and the kind of recognition that one of the things that will need to be different to reassure people that commercial buildings are safe to go back into and use, and to provide a sort of quality environment, is around ensuring that those buildings are well ventilated with plenty of fresh air. That's a kind of classic example where that can work against making the building as energy efficient as possible. You know, closing it up, trying to reduce airflow to the minimum that you can kind of get away with, is kind of working kind of counter to that. But I think there's enough, to be honest, to go at that doesn't have to become a major issue. There are so right now, because of where we are with the sort of the state of development of various technologies, there is no doubt to go to a fully net zero carbon building today, you're almost certainly that is certainly going to cost more than kind of one built to code. But there is a lot that we could do today in new buildings to make really, really significant reductions. I was quite struck. The UK Green Building Council actually hosted a session in Manchester about 18 months ago, where they got a group of people together, both project owners and consultants, designers, contractors who'd worked on new buildings, not aiming to make them net zero, but where the client had set a brief around clear brief around actually minimizing energy consumption. All different types of buildings, different approaches they'd taken. What was really interesting was the quite a consistent message that they'd actually reduced energy use of those buildings by between 50 and 70% at no additional cost to no additional build cost and no extension to program, just by thinking kind of more clearly and cleverly and having a clear direction in the brief up front from the client that energy consumption, energy demand was a real priority, and they had to focus on it and set sort of targets and ambitions around that. So there is a lot that we could do today, albeit we do need further advances in some of the technologies, but we could make big differences right now in terms of the buildings that we put in place.
Thanks, Simon. Thanks. Jen, you've got your hand up. Did you want to come in?
Yeah, it was just on the point about, you know, are buildings going up now? Are we going to have to be then retrofitting them in the next kind of, you know, 5-10 years? And I think something that we certainly come up against is where the technology is all there to be used, but there's a huge gap in education and actually what it is and how it works. You know, we walk onto like mostly our larger sites that have got slightly more complex systems, and they're capable of doing absolutely everything that that client wants, but perhaps they've you know, not kept up with actually maintaining the system, or they've purchased it without really understanding exactly what they have and how it works and how it operates. You know, we have the situation all the time where people are saying, you know, we've disconnected all the systems because they weren't working, and what they were doing was the air conditioning was going off when the windows opened. So it wasn't not working, it was a huge education piece that needed to be done with that client for them to understand it. And I think there's probably going to be a lot of unnecessary spend with the technology going in if people aren't then educating the people that are inhabiting that building, what it is, how it works, and people can procure smarter, understanding exactly what they're buying and what they've got.
Brilliant, thanks, Jen. Myles, can I come back to you? Just because we're about to wrap up, and I just, one of the things I like about Peel is unbridled ambition is a signature of Peel, without a shadow of a doubt. And I'm also very fond of the notion of BHAGs, big, hairy, audacious goals. So I just wondered, you know, in a sneaky sort of secret box at Peel HQ, what's the next big thing? What's the big goal that you think you might be driving towards?
I'm sure there's quite a few, actually. Next big goal is, I think there's not one thing. It's continuous advancement and continue. And we have to be ambitious. Yeah, everyone has to be ambitious and strive for the best. And you know, we're very clear. We have short-term development goals and then medium and long-term. And I think that's and we're very committed to the low carbon agenda, very committed to the circular economy agenda. So we've got a long-term vision of where we want to be on across lots of different developments, whether it be our strategic water developments or whether it be in energy, whether it be in the residential schemes we do in the home building. So we've got so it's not one thing. I think when we discuss the future, we do discuss 10-year timeframes and 20-year timeframes, as well as just the typical 1 to 5 years. So no, it's not one thing, Steve, I'm afraid. And if there was, I probably couldn't tell you.
See, I knew that. I knew there'd be a whole top secret Peel master plan that we don't get to find out about this morning. We'll go away disappointed. There'll be no round of applause. Anyway, last thing for this session, which I wanted to come back to you on, Alex, which you mentioned a moment right at the start, and it's a geeky thing because I'm passionate about it. Why aren't we building more buildings out of wood? Why, you know, it's a perfect, brilliant resource. Should we be seeing more timber frame buildings around the city?
I think it's definitely got a part to play in the next sort of 5 to 10 years. I think there are a number of challenges around timber. Fire issues is a big one, and then the knock-on effect of potentially not being able to insure a building, or higher insurance rates. You know, that's a big concern. Obviously, there's, you know, with there's been a few issues with fire in this country relatively recently, which are fresh in people's minds. I think there's also, once you get above a certain height, it really doesn't lend itself well. But I think also one of the other things which really needs to happen is the decarbonisation of industry. So, you know, if you say, well, you know, concrete and steel are huge consumers of carbon to get them to site. Well, if we're able to decarbonise the manufacture of concrete and steel, then straight away your embodied carbon footprint of the building comes down, and you know, maybe hydrogen is a key part to achieving that. And you know, we might be building loads of buildings out of timber in the next 5 years, and then the hydrogen comes in and it's more readily available, and then straight away everybody flips back to concrete and steel because the embodied carbon of those two products is significantly reduced straight away.
Thanks, Alex. Not as pretty though. Let's face it, the timber's lovely. I'm going to wrap us up there. I want you to all imagine that absolutely raucous round of applause from the audience as you go out. So thanks ever so much, Alex, Myles, Jen, and Simon. That was absolutely brilliant. I'm going to bring us to a pause now for a quick break. We're coming back at 11 on the dot for a look at transport and decarbonisation, the race to zero. And then after that, some key areas of green innovation. So we've got a quick break now until 11 o'clock. Thanks very much. Cheers.